Okay. Hey everyone, Happy New Year 2026. This is the first meeting for the year 82. Today is Jan 13. Thank you for showing up. Let's start. If you're a new member, we have few new members. I don't know if they are here in the session, but if you are, welcome. We are meeting every month, usually Tuesday, usually 5 p.m. To admit people as I speak. Uh, Usually 5 p.m. On Tuesday. And if you have anything that you would like to present, please let me know. Um, I can help and anything that you learn while you prepare that is a great experience. So and anything works from something few minutes to the entire hour or less. Okay, so yeah, my name is Kobi. Most of you know me. I'll skip that to the actual meeting. We have about 1,874 members. At least that's what I was looking a few hours ago. Uh, Thank you, JetBrains, for sponsoring the meetup fees, which are not small. Unfortunately, this is a few $100 that JetBrains are chipping in for us. Thank you, JetBrains, for supporting the community. Um, this is what I'm reading. This book I'm reading on my free time. Received that from Packet. There is a CPP20 code for the ebook if you want to try it out. This is actually a good book. The first few chapters are kind of really on the theory side, but it goes into a lot of details and very advanced details of C++. So I like it so far, by the way. So give it a try if you have a. It's a very big book. I have it here. I also have an ebook, but it's a very very thick book. I don't know if you can see it, but it's I don't know. It's like it's 700 pages, but it's good. It's good. There's a lot of advanced uh, idioms and paradigms that it's hard to see in other books. So I recommend that. At least from chapter 5 and on, it gets very very advanced. So worth looking at. Okay, let's jump to the agenda. We have a special guest today, um, Martin. And Martin will show us how to implement the equivalent of the C# property in C++ with syntax identical to regular C++ variable, maintaining full control over the read-write operations like pub/sub. He would show that, and underlying storage management. Martin shared that in our Discord, and I looked at that. I liked it, and I wanted him to provide a kind of a session for us to learn. Let's just before I hand off to Martin, uh, bio. By the way, this is the nice part is that I'm using Google Slides, and they have like Nano Banana now button. That's okay. Beautify this slide, not all slides, but some of them. So I take advantage of this. Okay, make it beautiful. So it takes text and creates these images. So Marty has been programming as a hobby since he was 8 years old, kid professionally for 25 plus years. In his career, he did computer forensics and data recovery, trade desk and automated trading software, big data and distributed systems, visualized storage and storage driver, remote app and desktop delivery. Finally, mobile device management. Currently in between job, actually starting very soon, a new position.
Yeah,
Congrats.
next week.
Uh, and yeah, I'll handle. By the way, Martin and I know each other just virtually many many years, and I publishing the summary of the meetup in his blog post that you can, by the way, mention that as well. Actually, I have a link in one of the slides. So, uh, Marty, I'm gonna stop sharing, and you can take over.
Okay, let me share my screen. I have some slides too, not as pretty as yours.
Well, it's
Let's
all AI today.
slideshow. Uh, okay.
It's okay. It's getting
Oh, maybe I'll just.
it was blurry. It's getting sharper now.
Is it okay?
It's getting sharper now. Yeah.
Yeah, I'll just show it like this. Um, yeah, so I wanted to just share some code that um, Kobe and a few others found useful. I always liked the property concept in C sharp, and always wondered how this could be done in C++. And this actually started as a code review some years ago, um, with with a class having public data members, which we all know is a big no-no, right? So I thought to myself, now this should be a way to do this better. So I started working on this during Christmas vacation a couple of years ago, and then um, somebody at work has kind of forked it off and rolled with it. And but I've been quietly uh, and independently implementing bits and pieces of it until recently, where I rewrote a lot of it in C++20, um, and felt comfortable enough with it to write a blog post about it, which I did a few months ago. Um, so yeah, the basic motivation behind it was to improve code function while really keeping the syntax of having public data members, um, either primitive or complex types. But as we all know, public data members in the class, you lose control over who and what is dealing with them, modifying them. So I wanted a way to do something about it, um, while keeping the syntax identical, basically. Um, so just like in C sharp, you define a property, you can define the get and set methods for it. I wanted a similar mechanism for this in C++. I also wanted by default the size of a property of a type T to be the same as size of type T, so it wouldn't be affecting class sizes and layout. Um, by default, at least it wouldn't be, unless I'll explain more what I mean by default later on when we go to when I show you different property policies that modify how the storage is handled. Um, a nice bonus also would be, to get modification events just like in C sharp. So you have this property, let's say a string, and somebody or something assigns a new value to it, and you may subscribe to a modification event. So your piece of code will be called whenever somebody modifies it. Um, and another requirement that I had is that, well, I would still like to bypass this mechanism that controls the getting and setting, and still get explicit access to the underlying variable, if there's a variable, um, but never have it happened implicitly, um, by some implicit type conversion or something like this. Always and only through explicit syntax. And finally, I wanted these properties to work with not only primitive types, but also with complex types like STL containers and smart pointers, and support all set of operations, uh, like arithmetic and bitwise operators. So here's a simple example of bad code, right? We have a struct, public data member. You can uh, create an instance and assign to the data member, um, and it's not great. I mean, for plain old data, it's fine, but for anything else, you're breaking encapsulation, right? You're losing control over your data. So a better way would be to have something like a property. Uh, and here's an example. of how you could use this. So again, you have a struct, you have this time a property of type standard string, and in a constructor here, you're able to register an update proc, I call it. So for each property, you can set a unique update proc, a lambda in this case, which whenever this property is modified, um, this piece of code will be called, and you'll know that somebody's modifying it. So creating an instance of G and then doing G.ps, the property of string equals something. In my test program, it will emit an event and it will print this. So that's the super most basic usage example. Now, I was going to create multiple, many more slides with usage examples, but I figured it might be easier to just jump straight to the source code. So I'll do that in a second. But first, some implementation details about how this whole thing works. So the property, it is a class template, and it uses a policy-based design to specify the get and set mechanism. So currently, there is only one policy class that this template can be configured with, and that class right now controls the get and set mechanism as well as the underlying storage. And through this policy class, as I will show in some examples in a second, you can define where where the value is being stored. So the default property is configured with a default storage policy, which just has an internal instance of type T, so it's being stored in memory. But I do have an example of how to achieve the same, but store the value on disk. I don't have an example for Windows registry, but it could easily be done, or any other storage mechanism that you can think of. This implementation heavily relies on C++20 concepts to enable, disable members and operators. My implementation so far also comes with a bunch of helper methods that like make property, to kind of match things like make unique, make shared, and you can make property. There's a strip function, which is another way to get to the underlying value internal to the property, to bypass the getter setter mechanism. I've also added some template type deduction guides. And one example is that if you try to create a property of const char star, so like a const char star C-style string, it will actually, in fact, produce a property of std string. And I think there's a few more, and a bunch of macros to help finish the implementation. These macros mostly define member and non-member operators. So let me jump straight to that. Here we go. And I'll share a link to the blog post and to the implementation on GitHub. Can you guys see the font? Is it big enough?
It's fine for me. I
Readable
don't know
enough?
if others want it bigger, but it's like I'm good.
Okay. So yeah, this is the example program that's included on my blog post, which just basically illustrates how to create properties of different types, and how to set the update procedures. Here I'm just hard coding some numbers for the context pointer, but in the previous example on the slide was taken from here. So by default, and if you have a property inside a class, you would usually pass this. You would pass yourself as the context if you need to, or something else. Notice I defined few functions here, and I'll show you in a second how they are used. So just a foo, var, quas functions that take a string by reference, const reference, and so on. And this is to illustrate the implicit versus explicit access to what the property holds internally. Now, again, think of a property, right? The property of int is supposed to act just like an int would, right? The property of string would act just like a string, except you get to control how it's set and how its value. You can even control how its value is generated. So you could have a property called next Fibonacci. It would be a property of unsigned int, called next Fibonacci, and with the proper property policy class, it could keep track of being read, of its value being read, and generate next numbers in the Fibonacci sequence, for example. Or it could read a file of this, that may or may not be changing under. So note foo. So this would get you into the. Let me just see. There, this would call into the constant string reference call, passing a property. Let's see, where is P3 defined? There. Okay, so P3 is a property of string. P1 is a property of string that is being copied into P2 and moved into P3. So P3 is a property of type standard string, passed through a function call. It matches the foo with the const string reference. And this is okay because it's an implicit user conversion, but returns a constant reference, so it's fine. These calls here, this call here, because it uses the operator, the property overloads the dereference operator, which actually gives you a non-const reference to the internally contained member. So this is an example of how you would get access to the underlying variable that this property holds, and a bunch of other examples here. Let's see. I've got some examples here for properties that hold complex types. You can, let's say, if you have a property that holds a standard string, I've added an invoke method on the property, so you can pass a member pointer and invoke it onto the property. I don't know if this is really much use for it, for this particular invoke call, but I added it regardless. And to kind of match the std as const, I've added an as volatile, which I don't think C++ standard has yet. Here is another example where properties are being compared. So this illustrates some of the operators, comparison operator on a property. Here's some examples of properties that hold either ints or floats, assignment into a property. It also plays well with type conversions. So if you have a property of a float, but you assign an int to it, it will work. Or if you have a property of an int, or you try to assign a float, you will get proper compiler warnings. It will all work. Moreover, here's an example of more operators that work on a property. I picked auto here for all these types to illustrate that if you have a property, let's say property of an int plus a property of an int, the result will give you another property of an int. So as long as one type in our arithmetic expression is a property, the result will evaluate for another property. Let's see. Here is an example of properties containing STL containers. So you can have a property of a vector, which has with a what do you call it? With a concept, it will enable these array access operators, for example, if you have a property of a vector and so on, or a property of a map. I'm probably not showing you anything you don't know about STL types. It's just this example is meant to show that everything that you can do with a vector or a map and so on, you can do with a property of that particular type. The difference being that if you try to assign a new value of the type, you can control what's happening there. Finally, properties of unique and short pointers are supported. And let's see, there's more there. Strings. Okay, let's get to a more interesting example. So here is an FS property, so a file system property. So you have a property of file system property of type int, and it's using the standard file system mechanism to specify where you want this property to live. So this file system property of an int, again, it acts just like an integer. You can assign to it or you can read from it, but under the hood, it will go to a file system and read and write from and to disk. And I have these files here. So these files that were created using this code, you'll see int, float, double, and two, and string, and a white string. And if you can examine this value, let's see, there you can see that it's supposed to have 2 lines of text in there, by the way. So these are the files that live on disk that contain the data that was assigned to these properties in the program. So there is that. And here's the actual implementation. So I will briefly go over that. Like I mentioned, it's using concepts very heavily. So thank you, Stack Overflow, I believe, for helping me define a smart pointer concept that can tell you whether something is a smart pointer or not in C++. Same thing for a standard container. So I define these concepts to restrict what types a property can hold. Then I define some non-pointer, non-reference, and finally, basic property type has to be a non-pointer, a no-reference, or a smart pointer, or a standard container. And based on that, here is the default basic property policy, which is where by default the actual value is stored. And here, besides a bunch of special members like constructors and so on to control the creation and moves and copies of this, at the heart of it are these methods of this property policy, which give you the get constant and const volatile get and set for a value or copying and moving. So this is what's being used by default and to implement the same property, but as something stored on a file system, you again would implement another property policy, except here the get and set methods are implemented as doing access to disk. So that's that, the getters and setters for it. And finally, the basic property. It's if you're really interested in this, you really got to sit down and go through it slowly. I'll just go through it quickly. So some standard operators, comparison operators. Like I mentioned, macros help me define all various kinds of operators. So These are member operators, which I then duplicate through the use of macros. There is some typecast operators. Notice that the one that returns a reference is an explicit one because I want that to be explicitly meant by the user of the property. Because once you cast it to a non-constant reference, you can then effectively bypass the get and set mechanism. So I wanted that to be done explicitly. Bunch of other special member operators like the pointer access operator, dereferencing, address off, and so on. And again, they all fall back onto the policy's get method every time. So regardless how you try to access the value, it should always go through the policy class. More of the same, but for different types. So these are the versions that require when you're holding a smart pointer. The inner workings of it is slightly different, so that's why they are duplicated here. But you'll never have this one and this one at the same time. It's because it uses concepts. It will either enable one or the other depending on what the property holds internally. Some array access operators. Also to make it play nice with not just with standard containers, but with more standard functions that work on standard containers. I've implemented the begin end methods and constant begin, constant end, and so on. So, for example, a property of a vector can be used inside a range-based for loop, and it will just work because of the presence of those things. You saw the invoke. So this is a mechanism to invoke a method of a object that's being held internally by the property. Some stream output operators defined as friends, so you can neatly, if you have a property of something that's printable through an output stream, you can print a property of that from the same stream. Same thing with input streams. And the updates itself, the update event dispatch, the way I did it is there is a static map internally or a hash table that maps the property to a corresponding update function. So it's perhaps not the most efficient way of doing this, since every time a dispatch needs to be, or the update event is dispatched, it has to find it in the map, and if it finds it, then it dispatches the event. So this could potentially be a performance hit, but I guess that's just, it is what it is. Basic template type deduction guides are here. So const char and const white char. These are just helpers to kind of translate what you're telling it to construct versus what it will actually construct. And finally, some of those make property proper functions for different scenarios. There's a lot of duplication, you could say, but from going through my testing of this code, all these functions, I found they were actually needed for different scenarios. So yeah, that's I think that's pretty much it as far as what I wanted to share. Do you guys have any questions?
Yeah, I have one. You mentioned that FS property type will go to disk every time you try to read or write to it. Is there any kind of caching mechanism built into it, or can you tell it like, don't go to disk whenever I write, just like keep it in memory for a while, and then I'll tell you later to write it to disk or something like that?
So there isn't in my implementation, but you could very well implement it. Um, this is still kind of a work in progress, right? But so in the implementation that I provide for the file storage property policy, no, there's no caching other than whatever the file system may be doing.
Yeah.
But because this property policy is inherited, um, you see, because the property inherits
Right.
this,
Right.
you could have you could add a constructor and destructor to these file storage property policy classes, and then maybe cache the value while it's being used and flash it to disk when it's being destroyed.
Yeah.
So yeah, this can definitely be achieved. It's just for the purpose of this, this my first edition implementation. No, there's no caching there.
Yeah. I mean, that seems like a subjective thing that other people would maybe like add at a later point. But that's good that like adding another layer to do what I described wouldn't require like writing a whole other class and their own, deduction guides and all the boilerplate you had to write all over again just to add like a little extra layer. So that's cool that the inheritance could be leveraged.
Yeah, exactly.
There.
You implement your own policy, and then let me find it. This and here. So this is how the FS property is defined. You just plug in a different storage policy or a policy.
Yeah.
So yeah,
Very cool.
you could implement cached file storage, or I don't know, Windows registry storage or something, and just define it and then use it freely.
Yeah. Gotcha.
The only thing is all these operators need to be redefined, and and the template the type deduction guides here. I found no way to define those for aliases. So I define them only for basic property, which uses the default policy. But those would need to be redefined for a different.
I see. Gotcha.
So like I said, it's a work in progress. So I only did it for one and not the other.
Yeah, I mean, it almost sounds like you're just running up against the limitations of C++ itself here.
It's at some point, yeah, it does feel like it. That there's only so far I can take it to match the syntax of C#.
Mm-hmm.
Yeah, that's I think that may be the case, but this is an open source project on my GitHub and on my blog, and I'm definitely happy to accept contributions, or you're free to grab it and go with it.
Sounds good. Yeah.
This was just more of a kind of a curiosity. It started off, like I said, it started as a code review, and I started implementing this a few years ago on Christmas vacation, and handed it off to a friend who ended up using it for something at work. And then I kind of sat on it for a while, and then as time went by and C++20 came around, and then I finally came around to learning it, I was like, let's see if I can rewrite it in 20. So I did. I did a complete rewrite of this several months ago.
Nice.
And yeah.
Thanks, Martin. I think but just by reading the property.h, you can unpack so many idioms and constructs from like advanced one from C++20, which is it's very good to understand.
Yeah, I did try to pack it with the latest and greatest,
Yeah, which is great. It's a great experience for everyone, for you obviously, and for everyone reading that. I have a couple things. One is because of the static map, you don't see it as a thread safe, right? That's one caveat that
yes.
That you okay.
And yeah,
And
the thread dispatching and registering the update proc is not thread safe. That's true.
And you can use it in like maybe in a thread local storage if this works for you, and then this is one way to get away with it. The second thing is like I don't remember when I was reading it a few weeks ago. The size of a property would include the callable object, right?
So no, it wouldn't, because it's not stored as a member. That's why there is a separate. That's why there's a separate map.
I see. Okay. So the size of int would be the size of a property of int.
Yes, but only for the basic property, for the default one that uses the default policy.
And the one that, what do you mean? Because the FS would have more stuff.
Mhm.
Would have
Yeah.
F
So right. So a way to optimize the file system property, would be right now in the get and set method, I create a new file stream, I open the file and I read it and I close it. Right. That's because I didn't want them to be members, because that could explode the size of the property. So it's a trade-off, right? Of size versus performance here.
Yeah. Yeah. Thank you. Anyone else want to ask questions? So you, in the meantime, you're gonna post it maybe again on Slack so people have it refreshed.
Yeah, I'm gonna share
Not
a link
Slack,
right now
sorry,
in the
on
chat.
Discord.
Yes.
Let
me just find a link to it.
And yeah, anyone else would like to ask questions?
Yeah, here's the link to the article.
Okay. So
in
the
the chat.
article probably has the link to the GitHub
Yes.
page. Okay,
Yep.
perfect.
Yeah, everything is there, and I'll share it on Discord as well. Again, I know it seems like a bunch of complicated mumbo jumbo for really, for something that looks identical, to this like a member variable. But that was the whole idea, that you write it, and from the standpoint of the user of a class, it appears as if the class has a public data member, and the syntax of it is just like a public data member. But again, the access to it, read and write, is fully controlled. Plus, you get the bonus of events, getting an event if you choose to, if said data member is is being modified. Plus, there are a few other shortcomings. So, for example, if you have a property of a vector, I cannot really easily detect that you are modifying an element inside a vector, right? So the modification event would be if you just overwrote property of a vector with another vector. Now, there's probably some fancy, complex way of detecting this, but I think it would get pretty complicated pretty quickly, because you will notice that the property has the square bracket operator defined.
Yeah.
So that if you're holding a vector, you can access an element inside a vector or a map. But the assignment is not going to emit an event. That's one important thing to remember.
Yeah.
Because it's a property of a vector, but the vector itself has a class that has inner data inside of it. So I could probably detect that you modified an element inside a vector, but it would probably require something like having that square bracket operator return a temporary object that looks at the index, queries the value from the vector, stores it in temporary, then does the assignment, then compares if you assigned it with a different value. So this can be done, but this could get pretty complicated pretty quickly, and that wasn't really my goal behind this. It was really just to, like I said, to give you as close of a syntax to C# property, if anything, at least for primitive types, because it works very well for primitive types. With complex types, it can get complicated, and give you those events when a value is being modified. But yeah, definitely not a thread safe. So that's one shortcoming as it is right now, which could be changed. right? At a cost of storage, each property could hold its own event handler, right? So instead of doing the lookup in a map to see if a event has been registered for this particular property based on the pointer, based on the value of this pointer, I think it's done. The property could hold it internally as a member, but then again, you're looking at increased size, and I really wanted by default the size of property of T to be the size of T. And it would make it thread safe, I think, doing it this way, or at least thread safer. Yeah.
And if you needed to have all the all the functionality of, let's say, the square brackets, like the subscript operator and all, so you needed to define them. How about like in place and all of that stuff? This is something that you would need to write, or maybe it's already there.
What do you mean?
Like there are all kinds of functionality. Like Vector, for example, has all kinds of functionality. Map has other functionality, like, let's say, in place or in place back, or
oh no, right. No, you can just access this through the pointer access operator.
okay.
So if you have a property of vector, you can do property and then minus greater than, right, size, for example.
I see. Got it. Okay.
Yeah.
So you basically access to the API of the property directly.
Yeah, of the contained value, exactly like the shared pointer does it, right? So on the shared pointer, if you do shared pointer dot, you get the member methods of the shared pointer itself. But if you do shared pointer arrow or pointer access, you get the methods of the contained object. So it works exactly the same way.
Okay.
Yeah, I try to mirror it as much, mirror it to resemble standard types as much as possible in that respect.
Okay, got it. Thanks. Any other questions? No. If not, we can let you go. It's late on your side. I know. Martin is on the East Coast. While we are most of us on the West Coast, I think. I don't know, actually. Thanks, Martin. Beautiful.
Yeah, my pleasure.
I'm gonna re-look at it now again. I've looked at it when you posted it, like, was a few months ago. Thanks a bunch. I'm gonna post.
Oh yeah,
Yeah.
One last thing. Another thing that's missing, I think, for the most part, is exception safety specification. So there you may find no except in a couple of places where it was really obvious, like the move constructor and the set method for moves. But everywhere else it's missing, because from my experience, adding this to every method, because it's an object that contains another object, so really all of that would require doing exception specification, all these operators and so on would require inspecting the underlying type, and that would explode the lines of code, it would double it probably at least. So that's why I omitted it, at least for now. I may come back and add full exception specification to every method, either being no except or being a no except conditional on the contained types behavior. So that's another thing that's still missing. Like I said, it's work in progress still, but I'm happy to take contributions and of course credit whoever wishes to contribute to it.
Yeah, thanks, Martin. Thanks a bunch. Okay, everyone, if you don't have anything to ask, and we can conclude that. Thanks a lot. Happy New Year again, and see you next time. Thanks, Marty. Talk to you later.
Yeah. Thanks, guys. Have a good evening.
Take care. Good.
Thanks.
Bye bye.